Hi guys, welcome to my channel. In this video, I am going to talk about process control block or PCB in an operating system. What is a PCB? A PCB is a data structure that holds all the information about a process. Whenever a process is created, a corresponding PCB is also created. For every process, a single PCB is associated with that. And this PCB is stored in the main memory. The structure of a PCB or the details that's present in a PCB that might vary from one operating system to another. However, there are some important information and these information are common across systems, and let's understand some of the important information that's available in a PCB. The first one is process ID. A unique ID is associated with every process, and this is nothing but the process ID. Then we have state. It can be ready, it can be running, waiting. That information is present in here. Then we have the priority. Whenever a process is created, a default priority is associated with that. During the course of a process, this priority keeps changing. Then we have registers. It can be program counter value or it can be processor status register. All those various register values are present here. Then I have memory info. It can have pointers to various sections of memory of a process. It can have pointer to a stack segment of a process, or it can have pointer to a data section of a process, or it can have pointer to a text section of a process where the machine code is present. So all this memory information is present in here. Then I have I/O devices. What are all the I/O devices required by this particular process? That detail is present here. Then I have file related information. What are all the files opened up by this process? Or what are all the details about those files? That is present here. Then I have CPU time. How much CPU time this process is taking? That information is present. Then we have time limit associated with the process. Then I have scheduling queues. Some details about scheduling queues and various scheduling parameters also present in the PCB. Now let's understand what is the purpose of having a PCB. Now that we know a PCB has all these important information, what is the purpose? As we can see here, state and priority. The state and priority can be useful in scheduling a process. Looking at the state, if it is ready, okay, then this can be scheduled. This process can be taken up for execution. We understand that priority, okay, this process has got higher priority, okay, then this needs to be scheduled before any other process which has got lesser priority. So we can say that state and priority is useful in scheduling a process. Then I have register values. This is particularly useful in context switching. How is it useful in context switching? When a process changes from, for example, running to waiting state, the register values are stored, the program counter values and the processor, what was the state in which the processor was when the process shifted from or transitioned from running to waiting state. When the process comes back into execution and it gets the CPU time again, these register values can be used and the process can start execution from the point where it stopped before, and it looks as if the process has never stopped. So these register values are particularly useful in context switching. Then I have memory info, I/O devices, files. These are all useful in releasing the resource. When a process completes its execution, these resources need to be released. So when I know that these are all the resources it's holding, I know what all things I need to release. So we can say this is resource management or memory management of a process. Then I have CPU time, time limit, scheduling queues. These are again useful in scheduling a process. So by looking at all these, we can say a PCB is useful in providing useful information about scheduling, context switching, resource management of a process. So overall, what we can say is a PCB is useful in process management or managing a process. Thank you.